Hello everyone, welcome to the series where we are covering quantitative aptitude questions from previous year UPSC CSAT papers from 2016 to 2025. In the previous few sessions, we covered questions on number system from previous year CSAT papers 2016 to 2020. And in this session, we will cover questions on number system from UPSC CSAT paper 2021. So, let's begin with the questions. Now question number 1 is, if 3 raised to power 2019 is divided by 10, then what is the remainder? Now to solve this question, we should know two things. First of all, when a number is divided by 10, then the remainder is always the last digit of that number. Okay. Second, here we need to know what is the cyclic pattern of 3 raised to power n. Right. Now what is the cyclic pattern? See, when 3 raised to power n, when 3 raised to power 1, the last digit is 1. When 3 raised to power 2, the last digit is 9. When 3 raised to power 3, last digit is 7. When 3 raised to power 4, last digit will be 1. Okay. So when 3 raised to power 5, last digit will be 3. Now after powers of 4, the digits will start repeating. Okay, so we can say the cyclic pattern of 3 raised to power n is 4. Right. Now we can write this number 3 raised to power 2019 as 3 raised to power 2016 into 3 raised to power 3. Here the last digit will be 1 and here the last digit will be 7, and overall the last digit will be 7. So we can say the remainder will be 7. So answer is C here. Let's move to question number 2. The number, we are given a certain number here, is divisible by 7. What is the value of the digit P? Now for this number to be divisible by 7, we need to find the value of P. First of all, let's divide this number into block of 3 digits. Okay, from right to left. It will be 369, it will be 25P, and it will be 981, and we added 0 here because we were left with 2 digits in the end. Okay, so we can also write these number as 250 plus P and 369. Now we add and subtract alternate numbers. Okay, now we will have 981 plus 369, okay, minus 37 plus 200 plus P. Okay, again we will have 1350 minus 7 8 287 plus P, and again when we subtract we will have 1350 minus 287 minus P, and when we subtract these it will be 1063 minus P. We can also write this 1063 as 151 into 7 plus 6 minus P. Now we see this number 151 into 7 is a multiple of 7. Okay, now for this number to be divisible by 7, we should have 6 minus P is equal to 0. Okay, now P is equal to 6. So answer is B here. Let's move to question number 3. Integers are listed from 700 to 1000. In how many integers is the sum of digits 10? Now here we need to find how many integers are there between 700 and 1000 in which the sum of the digits is 10. Now let's start writing. Now first we will have 17703, right? Then we can have 730, okay? Then we can have 712, 721, okay? Next 811, then we can have 802, 820, then 901 and 910. How many are these? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. So there are 9 integers between 700 and 1000, in which the sum of the digits is 10. Okay. So right answer is D here. Now question number 4 is, consider all 3-digit numbers without repetition of digits obtained using 3 non-zero digits which are multiples of 3. Let S be their sum. Further, we are given two statements and we need to find which of these statement is correct, right? Now, first of all, let's see three non-zero digits which are multiples of 3. Which are these digits? So, these digits are 3, 6 and 9. Now, the numbers made of these digits are 369, then 396, then 639, then 693, similarly 936 and 963. Now if we add all these numbers, then sum is 6993, right? Now let's see first statement. S is always divisible by 74. Now if we divide this number by 74, we get 54 above. So this number is completely divisible by 74. So statement 1 is correct. Now let's see statement 2. S is always divisible by 9. Now to check whether this number is divisible by 9 or not, first let's add all the digits of this number. Okay. Now if we add all the digits, we get 3 plus 9 plus 9 plus 6. We get 27. Now 27 is divisible by 9, right? So this complete number will be divisible by 9. So statement 2 is also correct. So here answer will be C, both 1 and 2. Now let's see question number 5. Consider the following addition problem, right? 3p plus 4p, pp plus pp is equal to rq2, where p, q and r are different digits. What is the arithmetic mean of all such possible sums? Now, if we closely observe this equation, right, then the possible value of p, which gives us unit digit 2 on the right hand side, are p can either it can be 3 or it can be 8, right? When p is equal to 8, when p is equal to 3, right, then the numbers on the left hand side will be 33 plus 43, again 33, again 33, and the sum will be 142. Similarly, when p is equal to 8, and the numbers on the right hand side will be 38 plus 48 plus 88 plus 88, okay, and the sum will be 262. Okay, now we need to find the arithmetic mean of both the sums. So arithmetic mean will be 142 plus 262 divided by 2. It will be 404 divided by 2, and we get 202. So right answer is C here. Okay. Now question number 6 is similar type of question again. consider the following multiplication problem. PQ into 3 is equal to RQQ, where P, Q and R are different digits and are not equal to 0. Further, we need to find the value of P plus R divided by Q. Now, if we write down this multiplication in the standard form, we can write it like PQ multiplied by 3 gives R Q Q R. Now, the value of digit Q here is such that when we multiply it by 3, it gives units digit Q in the final product. Okay, and the possible value of Q is here will be 5. Right, when we multiply Q or 5 by 3, we get 5 in the final product also here. Okay, so let's write here 5. Now when we multiply 5 by 3, we get 5 here, and again we get a carry. Okay, ahead. Now if we multiply 3 with P and add this carry, we should get 5 here. Now possible value of P will be 8. Only then we will have 5 here. Right, now if we multiply 3 by 8, we get 24, plus 1 carry, we get 5 here. Okay, and we get 2 here. So value of P, Q, R are P is equal to 8 and Q is equal to 5 and R is equal to 2. Now we need to find the value of P plus R divided by Q. Okay, now P plus R divided by Q will be 8 plus 2 divided by 5, 10 divided by 5, it will be 2. Okay, so final answer is B here. Now let's see question number 7. Again we are given two statements here. Okay, now we need to find which of the above statements are correct. Okay, now the statements are, statement 1 is the sum of five consecutive integers can be 100. Suppose we have consecutive integers n minus 1, n minus 2, n minus 1, n plus 1 and n plus 2. Now according to statement 1, if we add all these numbers, n minus 2 plus n minus 1 plus n plus n plus 1 plus n plus 2, it should be equal to 100. Now we see we get 5n minus 2 gets cancelled out with 2. We get 5n is equal to 100. N is equal to 100 divided by 5, we get 20. Right. So the numbers are 18, 19, 20, 21 and 22. Right. And if we add all these numbers, we get a sum equal to 100. So first statement is correct. Now let's check the statement 2. The product of three consecutive natural numbers can be equal to their sum. Now suppose we have the numbers n minus 1, n and n plus 1. Now according to the statement, n minus 1 into n plus 1 is equal to their sum, n minus 1 plus n plus 1. Okay, now here we have n square minus 1 is equal to 3n. Okay, minus 1 gets cancelled out with plus 1, and again we have here n cube minus n minus 3n is equal to 0. Okay, now n into n square minus 4 is equal to 0. So n is equal to 0 or n is equal to 2, right? So when n is equal to 2, the numbers are 1, 2 and 3. Now if we add 1 plus 2 plus 3, we get 6, and if we multiply these numbers 1 into 2 into 3, again we get 6. So statement 2 is also correct, right? So answer is C, both 1 and 2 are correct. Now question number 8 is the difference between a two-digit number and the number obtained by interchanging the position of the digits is 54. Now consider the following statements. Suppose we have the number is x into y. Now if we interchange its digits, then number becomes yx. Okay, now let's write these numbers in the expanded form. It will be 100x, sorry, 10x plus y, and here we have 10y plus x. Now if we subtract first number from second number, then we can write 10y plus x minus 10x plus y. Okay, and according to the question, this is equal to 54. Now we can see it is, we can write 9 y minus x is equal to 54. Now y minus x is equal to 6. Now statement 1 is the sum of the two digits of the number can be determined only if the product of the two digits is known. Now we have equation, we can say this is equation number 1. Now to find the value of x and y, or you can say to find the sum of x and y, first we need to find the value of x and y. Now for that to find the value of x and y, we need another equation. Either we should have a product of x or y, or ratio of x or y. Okay, right? We can find the sum of two digits if we know the product of both the digits or the ratio of both the digits. Only then we can find the sum of two digits. So statement 1 is not always correct. Okay, now let's see the statement 2. The difference between the two digits of the number can be determined. Obviously we have already find y minus x is equal to 6. Whether this number is greater than the first number or first number is greater than the second number, we will always be able to find the difference. So statement 2 is always right. Okay, so here answer will be 2 only. So that's all for today. If you find the session useful, then please like, share and subscribe and support our channel. Thank you.